Alrighty, CNT120, Chapter 3, we are now on to our IP address. So IP address, network layer address, this is used by every interface, every network connection that a node has on a network to identify that. As we said before, obviously identifying my PC, but if I think of something like a router that has, an in and an out port, a WAN port and a LAN port, each one of those interfaces on the router will have a unique IP address as well. So on the router, think of it as identifying the streets, Main Street versus Elm Street. Each one of those will have a unique IP to identify those networks. This can be used, IP address can be used to find a computer in the world. As we said before, the IP address is getting used to find the correct network. MAC address is getting used to find the correct device in that network. I'll mention that again here in a minute. IP addresses are used for routing purposes usually, and can also be called, or there's multiple different names for IP addresses, logical address, because there is actually some logic to it. As I look at the different numbers in there, they sometimes can mean, this campus of hack as opposed to this campus of hack kind of thing. It's also called a software address because we can actually set this in software and change it. A layer 3 address because it is layer 3 of the OSI model, and network layer address because that is the name for layer 3 of the OSI model. So remember those multiple names. Again, you hear a couple people talk, read a couple books, read a couple articles, you'll see it referenced by different names by different people. There's the traditional IP version 4 address. That is a 32-bit number written as 4 decimal numbers. Here would be an example of an IP address. Each one of those, when I convert it into a binary number, is 8 bits long, a byte. So 4 numbers times 8 bits gives you your 32-bit number. That was, it kind of from the early days of networks, 80s, if you will, 70s and 80s, up until present day. More modern networks are using these are IP version 6 addresses. We have run out of IP version 4 addresses a while ago, so IP version 6 addresses have been developed and implemented to be able to make up for that, that shortage, if you will. IP version 6 addresses came on the scene early 2000s. This is a 128-bit number, so the idea here is we'll never run out of these addresses. And it is written as 8 blocks of hex numbers. So if I take a look here, each block here, we have 8 blocks. Okay, those are your hex numbers to represent. And if I take and convert them, I end up with my 128 bits. If I write these each out in binary, I get my 128 bits in total. Again, remember, networks recognize 2 addresses, the logical IP address and the physical MAC address. And as we said before, the logical address, IP address, is getting used by routers to route the traffic, that piece of data, to the correct network. So routers are reading the IP addresses and getting it to the correct network. Example, the York campus of hack as opposed to the Gettysburg campus of hack. So the router is going to read the IP address and get it routed to the York network as opposed to Gettysburg. And once it does, the router is going to kind of like wipe its hands and say, hey, I got you there. Somebody else will take over. Well, the switch at that campus is now going to read the MAC address and get that data out the correct port to that individual device. So the MAC address is then going to get used at that campus, at that York campus, if you will, to get the data to the correct PC in that network, in that LAN. So the IP address is getting used at layer 3 by routers to get it to the correct network. Once it's there, the MAC address at layer 2, switches are reading the layer 2 MAC address to get it to the correct computer at that campus, the individual device at that campus, if you will. All right, we can have a static IP address or a dynamic IP address. Static IP address is one that we manually configure. We actually type in the number to use, assigned by your network admin. This can be used for static devices like printers and servers. And I typically want things like printers and servers to have a static number so it's not changing, so we can always find it in the network. So something like a printer or server, I would code that in so it does not change. But usually in a network, humans can make errors. So a lot of times all the other addressing in the network is done dynamically, which we'll get to in just a second. So statically on my PC or my server, I actually choose the option that says use the following, and all of these open up, all these become available, they're not grayed out, and now I can key in the IP, subnet mask, gateway, and so forth. But I need to key all that in correctly. One number off and things may not work, or this might not even accept what you're trying to plug in. So it is very particular. But I do that to statically assign it. It will stay that number. We'll always be able to find that printer, that server, that device. For most other addressing in the network, dynamic gets set. So your client computers, think about, the users in the network. Most users in the network are not going to be able to key all this in correctly and not make a mistake. So most of your client computers, most of your client devices, most of your user devices, we handle through dynamic addressing. When that computer starts up, it actually asks out on the network like, hey, is there an addressing server out here that can give me an IP? And we usually have a DHCP server somewhere in the network that says, yes, here's a number you can use. Here's the IP, subnet mask, gateway, all the stuff you need. Here it is. Use this and you'll be able to be on the network and good to go. So if I set my computer for a dynamic, I'm now letting a server give me the proper addressing. And again, this usually gets used for desktops, laptops, that sort of thing in the network. So users do not need to key this information in. So on my PC, this would be set for obtain IP address automatically. It is going to get it from the network, from the server on the network, and plug in all this information for you. Now, if my computer is set for dynamic, like so, and there's an issue where it can't find the DHCP server, and it can happen through cabling issues, it can happen through connectivity issues on, the computer itself is in the wrong port on the switch, it's in the wrong VLAN, those types of things. If it's set for dynamic and it's trying to find the server and it can't, the computer tries a little bit, and after a bit it's like, hey, I can't find the server. What it now does is does an automatic IP address assignment. And it will assign itself an IP address, a private IP address, in the range of 169.254. That it'll start with 169.254 and use that range of numbers. So if my computer is set for dynamic, it's trying to find a server and it cannot. After a bit, it gives up and it self-assigns a 169.254. That's a private address that's for local use. So if I always say in our lab room, if all the computers self-assign 169.254, we could communicate between each other in that room. But if we try to get our traffic tries to get outside of that room out to the internet, it's not going to work because this is a private local address. So most times in a network, if we're set for dynamic, which most clients are, and I sit down and I see an APIPA address 169.254, I know there's a connectivity issue and I need to start troubleshooting and resolve that issue. You normally never want to see this address on a computer. It's usually indicating you have a connectivity issue and start troubleshooting. So I always joke to people, when I see that little bottle rockets go off in my head letting me know I have a problem, I need to start troubleshooting. With my IP addressing, there's a couple pieces, whether I set it myself or have the server assign it to me. The first is the actual IP address. This is identifying that node, that computer, that printer, that server on the network. And usually the beginning part of the address is identifying the network, and the last part would be identifying this computer or this node. There is actually some logic to it. So I might say, hey, this part over here is identifying, your campus of hack, and this last digit out here is identifying this computer. The subnet mask that's with it is usually that decoder that tells you what part is identifying the network and what part is identifying the host. So when I look at these numbers here and see 255, 255, 255, those are telling me the first three up here are identifying the network. Again, the York campus of hack or the Gettysburg campus of hack. And that last number is identifying that node. That's what the 0 is letting me know. They're like, hey, that's identifying the host or the node. The next address that's in here is the default gateway. Well, the default gateway is the router or gateway device. It's usually a router, but the gateway device that is going to get me out of my network and outside and usually out to the internet. So this would be the router at, again, we keep picking on the York campus of Hack. This would be the router at the York campus of Hack that's going to route me from the LAN, the Hack LAN, out to the WAN, out to the internet. That's the address of that device. So that's the address that's going to get me out the door and out to the internet. Last but not least, we have DNS down here. This is the address of a server that can resolve the names I type into IPs. So when I type in my browser www.hack.edu, that request goes to the DNS server and turns that name, hack.edu, into an IP address, gives it to me and says, here you go, this is what you're actually looking for, and now I can go have that traffic routed to the Hack web server and give me the web page. So the DNS server is the address of a server that's able to resolve the names I type in my browser to IP addresses so I can actually go to that thing, that web server, and get the website. That is the address that is going to resolve those names to IPs. So on my Windows computer, if I type ipconfig, I'll see the IP addressing information. If I'm on a Windows or Apple or Linux machine, I can use ifconfig, and that will show me my IP addressing on my machine. There is such a thing as a subnet. I'm going to give you the idea here. This is something that we tackle very heavily in CNT125, the following class. A subnet is a smaller piece within inside the network that we use for organizing the network to help with security, traffic control, those sorts of things. So if I have a large network, I don't want everything out there in one giant pool. I might break it into smaller pieces so that I have maybe departments or types of devices segmented off in a smaller part of the network. This is all done by your network admin. So if I have a large network, a 172.16 network, and I see here 255.255.0.0, so I have a lot of, this is the network part here, this is the host part. I have a lot of host addresses here. I don't want that as one giant network. What I would probably do is start breaking the network into little pieces so I can allocate a little piece to maybe the office computers, the desktop computers, a different piece to the IP phones, and then a different piece for wireless users, the access points and the wireless users. Now I have three distinct groups that I can keep their traffic separated, and I can even filter them as to what they're allowed to do. So subnetting is a way to take a large network, break it into little pieces for organizing security, traffic control kind of thing. We spend a lot of time in CNT125 figuring out how to subnet, doing subnet, and applying subnets in our network. Okay, when I come back in the next podcast, we'll start wading into some specifics on IP addressing.